Hello everyone, good evening. So here we shall start from question number 12 onwards, right? So here it is given that ABCD is a trapezium. ABCD is a trapezium in which AB is parallel to CD and AD equal to BC and AD equal to BC. A is parallel to CD and AD equal to BC. Then we have to prove that first part is angle A equals to angle B. Second part is angle C equals to angle D. Third part is triangle ABC is congruent to triangle BAD. And fourth part is diagonal AC. Diagonal AC that is equal to diagonal BD. So the proof. So first we have to do some construction. First we have to write one construction, that is that a line is drawn. The line is drawn through the point C, which is parallel to DA, which intersects AB extended at the point E. So then we'll write the proof. So therefore, here we can see that in quadrilateral ABCD. So here one quadrilateral AECD has been formed. So in quadrilateral AECD, AE is parallel to DC, since it is given that AB is parallel to DC and AD is parallel to CD, which is according to construction. So therefore we can say that AECD is a parallelogram. AECD is a parallelogram since its opposite sides are parallel. Since its opposite sides are parallel to each other, AD is parallel to C. Okay. Now, therefore, we can see that AD will be equal to C. The diagram is like this. This is A, B, C, D. So therefore, we can say that AD is equal to CE and AE equals to DC. Since opposite sides of a parallelogram are equal, opposite sides of a parallelogram are equal. And also, you can say that angle A equals to angle C and angle D equals to angle E. Since we can say, since the opposite angles in a parallelogram are equal, so now can see that. So these two angles are equal, these two angles are equal, and these two angles are also equal. Now, now this angle is equal to this angle. AD equal to BC has been told, and AB parallel to CD has been told. AD equal to BC also has been told. So now I can see that AD equals to BC also, which is given. So therefore, in triangle BCE, BC equals to C, since both are equal to AD. Since both are equal to AD. So therefore, so these two are equal. It has been told these three sides are equal. So therefore, I can say that these two angles are also equal. So therefore, I can say that angle CBE, that is equal to angle CEB. Since opposite angles, since I can say the angles opposite to the equal sides of a triangle are also equal. Angles opposite to the equal sides of a triangle are also equal. So now, therefore, I can say that now angle A plus angle E, that is equal to 180 degree. Since they are co-interior angles are equal, since co-interior angles are equal, as AD is parallel to C, AD is parallel to C. Now, angle E is equal to angle CBE. Also, angle ABC plus angle CBE, that is equal to 180 degree, since it is forming a linear pair. So therefore, I can say that angle ABC, that is equal to 180 degree minus angle CBE, which is equal to 180 degree minus angle CEB. CEB means angle E, or I can say 180 degree minus angle E. So it means it is angle A. And so I can say angle ABC is same as angle B, so angle B equals to angle A. So hence proved. So the first part has been proved. Angle A equals to angle B, and similarly, angle C So this angle equals to this angle also. And also angle C or angle PCT, that is equal to uh, angle EBC, since their alternate interangles are equal, as AB is parallel to DC. The angle C equal to angle B. Angle C is equal to angle B also. No, yeah, angle CB, and angle EBC, that is equal to angle. This angle is equal to this angle, and this angle equal to this angle. And EBC equal to angle E also, and angle E equal to angle D also. So I can say that angle D is equal to angle C. Since why EBC is equal to angle C, angle EBC, this angle is equal to angle C, and angle E equals to angle D, and these two angles are also equal, so these two angles are also equal. So this is also proved, part 2. The second part has been proved. And we will show that triangle ABC is congruent to triangle BAD. This was ABCD, and this is E. So we have to show that ABD is congruent to ABC. ABD, okay, ABC is congruent to triangle BAD. Now here I will tell in triangle ABC and triangle BAD, basically AD equal to BC, AD equal to BC, which is given, and AB is the common side. AB is the common side, and angle A equals to angle B, or I can say that angle BAD, that is equal to angle ABC, which is proved earlier or proved above. So therefore, I can say that triangle ABC is congruent to triangle BAD by, so we have used side, angle, and side. The angle is the included angle in between these two sides. So I will say that triangle ABC is congruent to triangle BAD by SAS rule of congruency. SAS rule of congruency. And then diagonal AC equal to diagonal BD. So I can say that AC equals to BD by CPC2. So hence proved. The third part and the fourth part has been proved. So then here it is told that ABC is an isosceles triangle. ABC is an isosceles triangle in which AB equal to AC, think this is not the diagram. Now, and question number 13 is told that ABC is an isosceles triangle. ABC is an isosceles triangle in which AB equal to AC and AD bisects the exterior angle PAC. So here, because this is ABC and AB equal to AC, it has been told, and AD bisects the exterior angle PAC. The exterior angle will be formed like this. It's PAC, AD bisects it, and CD is parallel to AB. So these two angles are equal. And CD is parallel to AB. So that DAC equals to BCA. DAC is equal to this BCA, and ABCD is a parallelogram. So that we have to prove. It is given that triangle ABC is isosceles. Triangle ABC is isosceles in which AB equal to AC, which is given, and AD bisects the exterior angle PAC, and CD is parallel to AB. Then we have to prove that first part is angle BAC, that is equal to angle BCA. The second part is ABCD is a parallelogram. ABCD is a parallelogram. Then the proof is now here it is given that angle ABC, that we can say that is equal to angle ACD, since the angles opposite to the equal sides a triangle are equal. Since it is given that AB is equal to AC, so these two angles are equal. Now, also angle DAC, that is equal to angle DAP equal to angle PAC by 2, since AD is the bisector. AD is the bisector of angle PAC. Also, we can see that angle PAC, that is equal to angle ABC plus angle ACB, which is equal to twice of angle P, twice of angle ACB. Since we can say that since the exterior angle of a triangle is equal to the two opposite, is equal to the sum, is equal to the sum of the two opposite interior angles. Two opposite interior angles. So now therefore we can say that angle ACB, or I can say angle BCA, that is equal to half of angle PAC, which is also equal to angle DAC. So therefore, so hence therefore you can say that angle DAC, that is equal to angle BCA. So hence proof part 1. So part 1 has been proved. And we have proved that ABCD is a parallelogram. So therefore here from here we can say that AD is parallel to BC. It is parallel to BC since alternate interior angles are equal. Since this BCA and DAC, they are alternate interior angles. So since alternate interior angles are equal, and here obviously this B is the transversal, or BA is the transversal. Therefore, you can say that in quadrilateral ABCD, in quadrilateral ABCD, AB is parallel to CD. AB is parallel to CD, which is given, and AD is also parallel to BC, which is proved above. Is proved above. So therefore, I can say ABCD is a parallelogram, since its opposite sides are parallel. Since its opposite sides are parallel to each other. Parallel to each other. So hence proved part 2. Hence it is proved part 2. And here it is told two parallel lines L and M are intersected by a transversal P. Two parallel lines L and M are intersected by a transversal P. Within here it is told two parallel lines L and M are intersected by a transversal P, so that the quadrilateral formed by the bisectors of the interior angles the rectangle. So this is the angle bisector, this is another angle bisector, this is another angle bisector, and this is another angle bisector of the interior angles. So let's call it as this is suppose AB, this CD, this E, F, this is P, Q, R, S. So now you can see that it is given that L is parallel to M and P is the transversal. P is the transversal. Or I can say that CD is parallel to EF and AB is the transversal. AB is the transversal which intersects CD and EF, D and EF at P and R respectively. P and R respectively. Now the bisector of angle CPR and the bisectors of angle CPR and angle ERP intersect each other at Q, and the bisectors of angle GPR and angle ERP, no, angle FRP, it is FRP, bisect each other or intersect each other at S. So here we have to prove that the quadrilateral which is formed by the bisectors of the interior angles means PQRS, that should be a rectangle. We have to prove that PQRS is a rectangle. PQRS is a rectangle. So here obviously it is shown that these two lines are parallel. So the proof is that angle CPR that is equal to angle FRP. Since alternate interior angles are equal, and obviously PR is the transversal. PR, or I can say AB, is the transversal. Similarly, angle DPR that is equal to angle ERP. Same thing, since alternate interior angles are equal and AB is the transversal. AB is the transversal. So therefore, I can say now that angle QPR that is equal to half of, and we can say, and angle QPR is equal to half of angle CPR and angle SRP is equal to half of angle FRP. Since the reason is that since it is given that PQ and RS are bisectors, bisectors of angle CPR and angle FRP, which is given. And also angle QRP, angle QRP that is equal to half of angle ERP, and angle SPR, angle SPR that is equal to half of angle DPR. Since we know that here it is given also that RQ and PS are angle bisectors of angles ERP and TPR. Since QR, you can say RQ and PS. Since RQ and PS are bisectors of angle ERP and angle DPR respectively. Yeah, respectively. So now therefore we have shown that CPR is equal to FRP. CPR is equal to FRP. So half angle CPR that is equal to half angle FRP. Similarly, half of angle DPR, half of angle DPR that will be equal to half of angle ERP. So therefore we can see that half of angle CPR, it means it is angle QPR, is equal to half of angle FRP, it means angle SRP. And similarly, half of angle DPR, it means angle SRP, no, angle SPR, that is equal to half of angle ERP, which is angle QRP. So here we can see that we have proved that angle QPR that is equal to angle SRP, and we have proved that angle SPR equal to QRP. SPR that is equal to QRP. So hence it means the alternate triangles are equal. So QR is also parallel to PS and S and QR is also parallel to QR is also parallel to PS. So therefore we can say that QP is parallel to RS and QR is parallel to PS. QR is parallel to PS. Since we can say since alternate interangles are equal. Since alternate interangles are equal, and obviously where this PR is the transversal. PR is the transversal. So I can say that PQRS, the quadrilateral PQRS is a parallelogram since the opposite sides are parallel to each other. The opposite sides are parallel. So now we have to show that it is a rectangle also. We have to show, as you can see that now angle ERP plus angle FRP, angle ERP plus angle FRP, that is equal to 180 degrees since it is forming a linear pair. This is forming a linear pair, angle ERP and angle FRP. So half of that sum, that will be 90 degrees. So it means half of angle ERP plus half of angle FRP, that will be equal to half of 180 degree, which is equal to 90 degree. So therefore, we can see that half of angle ERP, it means it is angle QRP plus half of angle FRP. Half of angle FRP means SRP, angle SRP, that is equal to 90 degree. So angle QRP plus SRP, that is 90 degrees. So it means angle QRS, or I can say angle QRS, that is equal to 90 degree. Similarly, we can show that angle S, yeah, so that we can say that the angle CPR, not similarly, angle CPR plus angle ERP plus angle ERP, that is equal to 180 degree. Since why they are co-interior angles? Since they are co-interior angles, and since this CD is parallel to EF, and obviously this PR or AB is the transversal. PR or AB is the transversal. So half of them, the sum of half of them will be 90 degrees. So half of angle CPR plus half of angle ERP, that is equal to 90 degree, or hence half of angle CPR, it means half of angle CPR is QPR. So angle QPR plus angle half of angle ERP means angle QRP, that is equal to 90 degree. Therefore now QPR plus QRP, that is 90 degrees. So it means angle Q. So I can say that angle Q, or I can say that angle PQR, that is equal to 180 degree minus angle QPR plus angle QRP, which means since y, which is according to the angle sum property of a triangle. Angle sum property of a triangle, since the sum of three angles is 180 degree. So therefore angle PQR or angle Q, that is 90 degree. So this angle is also 90 degree. So it means that all the interior angles in this parallelogram is a right angle. So hence it is a rectangle. So therefore we can say that in parallelogram PQRS, all the interior angles, all the interior angles are 90 degree. Hence we can say that, hence since if we have shown that angle Q is a right angle, so the opposite angle will be also equal since it is a parallelogram. So angle Q is right angle, so angle S will be also a right angle. And since angle R is a right angle, so angle P also will be a right angle only. So hence all the interior angles are right angles, and it is a parallelogram also. So hence PQRS is a rectangle. So hence PQRS is a rectangle. So hence proof. Then here it is told to prove that, show that the bisectors of a parallelogram form a rectangle. The bisectors of the angles of a parallelogram form a rectangle. So here, suppose it is given that the bisectors of angle A and angle B in parallelogram ABCD meet at the point P, and the bisectors of angle C and angle D meet at point R. Also, AP and RD intersect at and obviously CR and BP intersect at P, intersect at Q. CR and B intersect at Q. So now we have to prove that PQRS is a rectangle. PQRS is a rectangle. It is good. PQRS is a rectangle. The proof is that so here we will get, so now angle SAT is equal to half of angle A, and similarly angle SDA, that is equal to half of angle D. Since you can see that since PA and RD bisect angle A and angle D respectively, which is given. And obviously angle A plus angle D, that is equal to 180 degree, since they are co-integers, and obviously AB is parallel to CD, as ABCD is a parallelogram, and AD is the transversal. And AD is transversal, obviously. So therefore, I can say that half of angle A plus half of angle D, that will be equal to half of 180 degree, which is 90 degree. So therefore, we can say now in triangle SDE, angle SDA, angle SAD plus angle SDA plus angle ASD, that is equal to 180 degree. Since why? According to the angle sum property of a triangle. So therefore, we can say that angle ASD, that is equal to 180 degree minus angle SAD plus angle SDA. Angle SAD plus angle SDA. So which is Now angle half of angle A plus half of angle D is 90. So therefore now we can say that angle SAD plus angle SDA that is equal to 90 degree. So this implies that angle ASD that will be equal to 180 minus 90, that is 90 degree. Similarly, we can see that angle QSB equals to half of, no, not QSB, QCB, which is equal to half of angle C, and angle QBC is equal to half of angle B. Since here it is given that RC and PB are bisectors. RC and PB are bisectors of angle C and angle B, angle C and angle B, respectively, which is given also. And also angle B plus angle C that is equal to 180 degree, since they are co-interior angles. And obviously AB is parallel to CD, and BC is the transversal, obviously. BC is the transversal. So therefore, we can say that half of angle B plus half of angle C that will be equal to 90 degree, which means angle QBC plus angle QCB that is equal to 90 degree. So angle QBC plus angle QCB that is 90 degree. And so therefore, we can say that angle BQC that is equal to 180 degree minus angle QBC plus angle QCB, which is equal to 180 minus 90, that is 90 degree. So now therefore we can say that angle PQR that is equal to angle BQC, which is equal to 90 degree, and also angle PSR that is equal to angle ASD, which is also equal to 90 degree. Since we can say that since vertically opposite angles are equal. So this is also 90, this is also 90. Similarly, we can see that angle PAB. Angle PAB that is equal to half of angle A, and angle PBA that is also equal to half of angle B. Since it is given that PA and PB are bisectors of angles A and B respectively. Since PA and PB are bisectors angle A and angle B respectively, also angle A plus angle B that is equal to 180 degree, since they are co-interior angles, are supplementary, as here it is AD is parallel to BC, and obviously AB is the transversal. So therefore I can say that half of angle A plus half of angle B that is equal to 90 degree, which implies that angle PAB plus angle PBA that is also equal to 90 degree. So now therefore we can say that in triangle PAB, angle APB that is equal to 180 degree minus angle PAB plus angle PBA. PAB plus angle PBA is according to the angle sum property of triangle. So therefore angle APB, that is also equal to 180 degree minus 90 degree. Since we have found that EAB plus BBA is 90 degree, so this is also equal to 90 degree. Similarly, we can show that similarly angle RTC, angle RTC equal to half of angle D, and angle RCT, that is equal to half of angle C. If RTC is half of angle D and RCT is half of angle C, since you can say that RD and RC are bisectors, since RD and RC are bisectors of angle D and angle C respectively, and also angle C plus angle D equals to 180 degrees, since they are co-interior angles, since co-interior angles are supplementary co-interior angles, and obviously AD is parallel to BC. It is parallel to BC, and obviously this CD is the transversal. Actually, CD is the transversal. CD is the transversal. So therefore, I can say that half of angle C plus half of angle D, that is equal to 90 degree. Which means that angle RDC plus angle RCD, that is equal to 90 degree. Now, similarly, in triangle RDC, you see angle RDC plus angle RCD plus angle CRD plus angle CRD, that is equal to 180 degree, since according to the angle sum property of triangle. Therefore, I can say that angle CRD, that is equal to 180 degree minus angle RDC plus angle RCD, that is equal to 90 degree. So hence here we can see that hence angle CRD, that is equal to angle APB, and that is also equal to, we have shown, that is equal to angle BQC, which is equal to angle PQR is equal to PSR. The angle PSR equal to angle PQR, that is equal to 90 degree. Now angle CRD, it means it is QRS. So I can say this is also QRS. Instead of APB, I can say SPQ. So all these angles are right angles. So I can say, so in quadrilateral PQRS, all the interior angles are right angles. All the interior angles are right angles. So hence we can say, hence PQRS is a rectangle. QRS is a rectangle. Or we could have shown it like this also, that since these two angles are right angles, so PS is parallel to QR, then this will be a parallelogram, like that also you can say, but it will take more time. So this is the easier way to solve. So hope all of you understood till the question number 15. So any doubts if you have, please write that in the comments. We shall obviously clarify them. So thank you everyone. Bye.